we pretty much know how to do these by now. I mean, this is Roman numeral 7. Okay, so we've done, obviously, 6 other types of compounds. If you did not draw this in here, draw it in there. It's right next to the thing. You have to draw it. I told you some of these I don't have on the top of your paper. But they're all going to be on that first... in that test, like I said, I told you I wanted to work the test out to be on a double period, and it will be. Friday will be a double period, which means you'll take both parts of the test. The part that's going to be on the properties, the general formulas, notes, which there aren't much of, all right, and the part that's going to be on the reactions. Both of them will be able to be done on the same day, so I don't have to worry about splitting them up. All right? Like I said, this shouldn't take me long. Maybe do 1 or 2 examples along these, because once you know the general formulas, it's more important we can put it together and do it right. All right? And that's why I want to go over this worksheet and get through this pretty quickly. All right, first of all, for the nomenclature, you're going to find that this is not much different than any of the other ones we've already learned how to name. All right? If I had this, let's hope everybody can at least do this. What would this guy be? What would that guy be? Ethanol, right? Okay. Well, guess what this guy would be? The difference is I've got my functional group here, right? This guy would be called ethanal. 1 letter difference between those two, which means this class isn't as bad as the other one. I've got Jacob and Jared in that class who can't write. I have to be able to tell an A from an O. That's the A, that's the O. Ethanol, ethanal. That's the only difference between them. Okay? That's how similar they are. Okay, so the nomenclature is very easy. You simply name the alkane and all that implies, which many people are just leaving out the rest of the alkane, and then you add an AL suffix instead of an OL suffix. So this is not, like, every time I add a new compound, every time I add a new type of functional group for the organic, it's not like I'm reteaching you a brand new concept. All right, this is the 7th thing we've done. They've all been done pretty much the same way. Okay, a couple of examples. Our most famous one would be this guy. And are also the shortest one. He is called what? What do you think? Methanal, as opposed to methanol. Make sure I can tell it's an A and not an O. But the reason he's most famous is, you know what aldehyde he is? It's the only thing that sounds like aldehyde you've ever heard of. Formaldehyde, exactly. That's what he is. Okay. By the way, do you see a pattern even amongst the common naming system, which I will not ask you on this test? Okay. We had common names like acetic acid and formic acid. Formic acid was this. That was formic acid. Notice this is formaldehyde, right? Form, obviously, when you see that as a prefix in the common naming system, which I'm not going to make you know for this test. I had to do it for the ester lab because all the chemicals were in there. But for the test, you don't have to know the common names. All right, you just have to know how to name it as methanal. All right, but form obviously means 1 carbon. Okay, and what would this guy be? Again, you don't forget about the methyl groups that are coming off of here. Okay? Put all the hydrogens around it, but that's what you look at. Oh, that's the other thing. I didn't, if you figure out 1 or maybe 2 places, I was relatively generous. But people who are drawing big, long compounds like this and just leaving it like that, all right? I told you from the first chapter I wouldn't let you do that. We're on the 3rd chapter already, and you have to fill them in. I have to make sure you understand, because sometimes there's going to be double bonds where you don't have just a hydrogen coming off everywhere. Sometimes there's going to be double bonds over here. That will be incorrect. You can't do that. And it kind of tells you that, all right, because you can't have 5 bonds around carbon. Anyway, what would this guy name be? 2-methyl propanol. And by the way, I don't really need to number the aldehyde. And here's the why. Here's the reason why. That carbonyl group, that double bonded O, has to be on the end to be an aldehyde. Okay? And by the way, as we're doing each of these, they take precedence. All right, the alcohols take precedence over the other stuff. The aldehydes this part takes precedence. I won't put more than one thing in there. Okay, so I'm not going to put both of them. I will next chapter. I'll have a carbonyl group with a carboxyl group with an OH, hydroxyl group. I'll have all these guys together. I'll tell you, actually I'll give you a chart that tells you the precedences, who wins. But in this test, this should be the easier one. I'm only giving you one at a time. But you can't forget that whenever these guys are in here, they're going to take precedence. So I don't say, oh, I want to call this guy, the methyl groups are over here. The methyl groups are over here. I want to call this 2,2-dimethyl. This is not 2,2-dimethyl, right? It's 1,2,3,4,4-dimethyl because this guy has to get the lowest possible number, just like the OH does, just like the carboxylic acid does, like a double bond does, like we've seen in the past, okay? Got to remember that, too. All right, so there's your nomenclature for aldehydes. Let's do the preparation of them. And these will not take long. As you can see, I only have room for really one example underneath this whole sheet. I'm doing that on purpose. In the beginning, I was doing an example of every single one. Okay? I'm doing fewer of them because you should know how to do these by now. And I want to also correct your mistakes today if I can. All right, so first off, I can oxidize a primary alcohol. It has to be a primary alcohol. Okay, if I oxidize a primary alcohol, what's going to happen? Well, it's going to take, this is what your primary alcohol looks like on your paper anyway. Okay? A primary alcohol means it's an OH on a terminal carbon, a carbon that's only bound to one other carbon. Okay? That will be a primary alcohol. If it's in the middle, this won't work. I'll point that out to you when I go over these worksheets where people were doing this for making carboxylic acids. Can't have this guy turned into a carboxylic acid. Can't have that guy turned into aldehyde. Can't do it. Has to be on the end carbon. If it's not, you can't do it. Okay, but many of you did, and especially on the back side. And I know that's something I expect is a mistake. Okay, when I go over that ester synthesis one on the back of the sheet, I expect mistakes like that. Other mistakes that are happening, I'm not really expecting at this point. But either way, let's go over an example of this guy. All right, let's take him. And believe it or not, I'm still getting people who are misnaming, it's hard to believe, guys like this. All right, it's the same, cast. Oh, here's another mistake. I just got done grading these, so they're very fresh in my mind. So I'm going to point them out to you as I see them, as they come to my mind. I had one person who on their entire sheet on the back did not put one catalyst down. Not one. Everything was just an arrow, a blank arrow. Never wrote down, lithium aluminum hydride, never wrote down H, never wrote down water, never wrote down anything. Just arrows. I mean, I don't know why you would think that will be acceptable. Or other people who didn't write any of the things they're reacting with. I mean, I don't know why you would think that's acceptable. I mean, it's not like this is the first ones we've done. It's the third worksheet, and I've done all these examples as part of these. So I'm not exactly sure where you're getting this from. Is it just laziness? In the first two I was thinking it was, well, they just didn't try. They were blank, they didn't really do anything. But this one, if you remember, I wasn't here the day you worked on this. You had the entire period to work on it with a sub, and you could have worked together the whole time. I have no idea why you would have that many mistakes. There's no real reason for that. All right. So what would happen here? I would simply say, oh, here's the next mistake. They're all coming to my mind because I just corrected it. This is what people will write. And think, oh, yeah, that's right. What's wrong with that? Yeah, you're not going to believe when you get your paper back, I can't believe I did that. I mean, multiple people per class just leaving out the methyl group that was over here and not putting it over here. I don't understand that. That's something that I stressed at least on the board 4 or 5 times now. And also corrected on you. I don't know why you're still making that mistake. It's not a mistake you should make. Let's go back to the naming. People still calling this 4 carbons long prop. It's not prop, it's bute. Okay? So people who are mixing up prop and bute, there's no excuse for that. 1,2,3 methyl. And you have to, and this is the biggest one. I think almost everyone on this last worksheet did not put the number for the alcohol, wherever there was an alcohol. In other words, they wouldn't call that 3-methyl butanol, even if they called it butanol correctly. It's 3-methyl 1-butanol. not 3-methylbutanol. You have to call it the one. I said anything bigger than 2 carbons, you have to name it. You have to number it, I mean. If you don't number it, I don't know when it's on. You have to do that. This guy, I don't have to, because the carbonyl group has to be on the end for an aldehyde. So this guy would be called 3-methylbutanol. All right? So, these are the mistakes. I'm pointing them all out to you as I've just graded these. And I pretty much pointed out every one I've seen, with the exception of, that's why I want to spend some time when I give these back to you, if I have time today, to go over the synthesis ones. That's a bigger deal. Those are that's what I expected to have to do. I did not expect as many mistakes on the front side of these worksheets. But these are the big mistakes you're making here. Okay? All right. Since I'm not doing any more on the sheet, all right, let me just recap again. Forgetting or losing methyl groups or ethyl groups. We're not writing the whole carbon. Not writing H's. Just writing the carbons. Not naming correctly still at this point. Not numbering the OH or whatever else, double bond, whatever else has to be numbered. Okay? All of those things are the common mistakes, the dumb mistakes, things that I know you know how to do, that you're still doing. All right. So, that's one way I can make an aldehyde, through oxidation of a primary alcohol. All right? I can also have reactions of aldehyde. By the way, there are more reactions in all of these. I'm giving you a minimal number, and they're all going to be on that sheet that I gave you anyway. Reduction to alcohols. I can reduce the alcohols by doing the exact opposite. Okay? And again, you have to keep the catalyst underneath it. That's another little thing I mentioned before. Not many people did that. All right. I don't need to do an example of this. I don't think. I could reverse the one I just did up there, but whatever I do, I'm going to take an aldehyde and I'm going to turn it into wherever that aldehyde was, that's where the OH is going to be. Okay? What's another reaction? Well, I can also convert these guys to acids. Right? I can convert these guys to acids. And again, I have this one here, I believe it says, next to it, what? What does it say next to them at the very end? Yeah, what does that mean? Yeah, I'm not going to ask you to balance this guy. Just trust me that potassium permanganate provides the oxygen. There is an extra oxygen over here, provides it for that, and I'm not going to ask you to balance this guy. All right, but that is, again, I would take. So if I took one propanol or propanol, I don't have to number it, I would get propanoic acid. If I took methanol, I would get methanoic acid. Simple as that. Okay. All right. Now I want to do ketones yet today. That's on the next sheet here. Aldehydes and ketones are very similar, as you'll see. That's why I want to do them on the same day. Maybe do an example of some of this, and then shut off the camera and do the actual, maybe some of the synthesis ones which you're having the most trouble with. Now, you've seen in this same place, by the way, you can see at this point how similar things are. Let's take a look here. We're about to get ketones. And if the ketones general formula, if it's not written in there already, and I don't think it is, looks like that. Okay, so write that down next to it. Now, I want to point this out to you. This is something that's going to cost you points on the other part of the test, not the reaction part. Okay? There's this guy. There's this guy. There's this guy. There's this guy. They all have this double bonded O in it, called a carbonyl group. All right? But they're not all the same thing. This guy is a ketone. What's this guy? The carbonyl group's at the terminal, at the end. We just did it. What is it? Aldehyde. You don't have to write this down. We already have these in your notes. What's this guy? A carboxylic acid. And what's this guy? An ester. By the way, the one thing I would hope by now you'd be able to draw correctly would be an ester. We had the ester lab, which had 5 reactions you had to draw, as well as the worksheet you had, as well as the notes you had. I mean, you probably have drawn out entire reactions of at least 10 esters by now. All right, but they all look similar. They all have that guy in there. And it's going to get easy to screw them up, easy to mess them up, isn't it? Okay, so I'm just warning you about that. One of those sections on the test is going to be just all of these guys labeled, or all of these guys, one or the other. And you're going to have to match them up. Which one's which? Okay? All right, let's go to ketones. What about ketones? Let's talk about how you name them. You name the alkane and all of that applies as we've done 100 times for different guys. You number the carbonyl group. This time you have to do that. You can't get away with just, carboxylic acids are always at the end. Aldehydes are always at the end. Well, these guys are not. They're in the middle somewhere. And then you add an O-N-E suffix. Okay, so we could try one of those. What would I call this guy for my example? Oops. What would that guy be called? Now, by now, this should be second nature to us. What do you think?
2-pentone?
The whole alkane, so it'll be pentanone. Yeah. 2-pentanone. And I don't think I've been really picky about the worksheets. I've tried to, like, if you didn't write every single dash around it, like there, I'm not going to take off. Okay? If you only did it in one place, but all the other ones you did, I didn't take off. But if you multiple times did this, or if you called pentone instead of pentanone, I didn't take off. You know, pentol instead of pentanol, I wouldn't have taken off. But if you leave out the number, I have to take off. I can't leave that okay. All right? I've been relatively generous, I think, grading these, and they still aren't good grades. Okay? How many examples do I have for you to put down there? 2? All right, so let's do another one. That guy would obviously be called 2-propanone. 2-propanone, which his common name is acetone. What do we use acetone for?
Nail polish.
Yeah. Nail polish remover. Use it. Probably use the solvent. Okay. I don't know. I don't use nail polish. All right. Now, you'll notice for this guy, I don't even have any examples down for this to be able to write in there. And I'm going to stop actually at ethers. I'm not going to do ethers today. I'm going to do them tomorrow. We have a double tomorrow. We'll have more time. I want to let you start working on the next worksheet. Well, let me just go through these really quickly. And I want to have time to also go over some of these other ones. I don't know what happened to my board that has those on there. But either way, you can just look at your paper, and you've got under ketones, preparation, oxidation of a secondary alcohol. See him there? Okay? Well, that's exactly the same. It's not only, it's exactly the same thing as you had in an aldehyde. All right? The only difference is you don't have a primary alcohol, you have a secondary alcohol. So wherever that OH was, if I were to do this guy, and the OH was here, that's where I'm going to get. That's where I'm going to get my ketone. And of course, you would fill in all the H's around there as well. Okay? And the same thing's true for the second one, which is reduction to alcohols, one of the reactions. It even has the same catalyst as the aldehyde one, platinum nickel catalyst. Okay? And you take your ketone, wherever the carbonyl group was, that's where you put an OH. I mean, I don't think I need to do examples of that at this point. We're on the 8th one of these. We've done a ton of these. You should know how to do that. All right, so I'm going to pause here.